Now in this question we have been given a random variable y that is normally distributed with the mean 0 and the standard deviation of the square root of 2. Now we know that the standard deviation, if we can relate the standard deviation to a variance in a way that the variance is a square of the standard deviation. So now this gets us the new random variable, or a parameter to be specific, such that we have a random variable y that is normally distributed with mean 0 and variance of 2. So now the probability density function of this random variable looks like this. But if we can take into consideration or take a look into our y random variable, we can see that it is squared, and the negative side will be equals to the positive side, because we know that if we take -2 and the square it, we get 4, and also if we get 2 and the square it, we still get 4. So this distribution is symmetric by 0, so we can have the symmetrical PDF. Now if we have the symmetrical PDF, now the bounds range from 0 to infinity, or just simply y is greater than 0. So now if we multiply by 2, okay, so I made a mistake here. Root 2 multiplied by 2 root pi, this will be just root pi. So this is just 2 multiplied by the square root of pi. So now if we multiply by 2 into the whole, from the left hand side into the right hand side also, so this is times 2 times 2, this will cancel with that, and then we are left with 1 over root pi e raised into the exponent of y squared divided by 4. Now y ranges from y being greater than 0. So now we need to transform the random variable u, that is just the square of y, using the transformation method. The transformation method, using the transformation method, that is the new PDF of the random variable u, will be fy, and we plug in the inverse of y, and we'll define it by this term, and then we multiply it with the absolute value of the first derivative of the inverse, deriving with respect to u. So now since u is equals to y squared, y itself, which is equals to this term, will be equals to the square root of u, and the first derivative of y will be 1 over 2 u into the exponent of 1 negative a half. So now plugging in, so now this is the PDF of y, but instead of y we plug in the inverse of y, that is this. So instead of this y squared, we are going to plug in square root of u instead of y, not y squared. So we'll have 1 over root pi e raised into the negative root u squared divided by 4, and then we multiply by the absolute value of the first derivative of the inverse. So the absolute value of this term will be this term itself, and then the constants, or the terms that don't have any variable on the side, so we'll have 1 over root pi multiplied by 1 over 2, that will be 1 over 2 root pi. and then we have u raised into the negative a half, and then e raised into negative u over 4. This is the PDF of u. And now we know that the bounds of y ranged from y being greater than 0, but then what is y now? Y in this case, in terms of u, it is root u. Now root u will be greater than 0. If we square both sides, u will also be greater than 0. So now if we take a look into this PDF, it looks like a gamma with alpha minus 1 being equals to negative a half and beta being equals to 4. So now alpha will be equals to 1 minus a half, which is just a half. So u looks like a gamma with alpha being a half and beta being 4. So how is that true? Let's check for the term in the gamma integral. That is 1 divided by the gamma of alpha beta raised to the exponent of alpha. So now that is, our alpha is a half. We have gamma of a half, and then beta is 4 raised to the exponent of a half. 4 raised to the exponent of a half, that is the same as the square root of 4, that will be 2, and then gamma of a half is root pi. Now 2, that is the square root of 4 multiplied by root pi. This term is the same as this term, so we can be confident that u is indeed a gamma. Therefore u is a gamma with alpha being a half and beta being 4. Thank you.